Okay, hi, I'm Lucile. As was mentioned, I'm a second-year student, PhD student at the Paris School of Economics, and I'm really thankful to be able to present my work on the impact of water scarcity on migration. It's a preliminary work, so I welcome every feedback and comment that you have. So water is essential for human life, health, and dignity. And climate change is expected to make water more scarce, more unpredictable, and more polluted, or all three. And the basic idea of the project is that if you lack water to meet your basic needs, then migration might emerge as an adaptation strategy. Migration as an adaptation strategy to climate change has already been studied, but at least in the economics literature, the main channel through which it has been studied is the agricultural channel. So that's you have higher temperatures or a decrease in precipitations, or both, and that leads to a reduction in agricultural yields and agricultural income, and that in turn leads either people to migrate or people to be trapped in their origin location. So if you think of migration as a continuum in between forced migration at one end and economic migration at the other, the mechanism I just described is closer to economic migration, and I want to focus on a different channel that is closer to forced migration because you are moving because of lack of water for your basic needs. Okay, and to find a setting where, and that's important because the selection into migration might be different. So if you're moving because of economic incentives, then often it's young males moving to the cities. And if you're thinking of forced migration, then children, women, elderly people might be moving, and the destination might also be different. So to find a setting in which water scarcity might affect migration, are also focused on Tanzania. In Tanzania, access to clean water is still a challenge. Around 60% of the rural population doesn't have a basic service in terms of drinking water. And I'm going to ask whether difficult access to water for domestic use leads to migration. Domestic use is cooking, drinking, and cleaning. Keep in mind that access to water is likely to be correlated with unobserved characteristics of households that are also correlated with migration. So to have some kind of exogenous variation, I'm going to exploit an interesting fact in Tanzania, which is that groundwater is crucial for domestic water supplies. So around 50% of groundwater extracted in Tanzania is for rural water supply. And around 50% of the rural population state that a groundwater water point is their main source for drinking water. And so I'm going to instrument water access with hydrogeological features and use those kinds of maps to have successful instrumental variable strategy. You have to comply with two main assumptions. Your instrument has to be relevant. I'm going to talk more into depth about that later, but it also has to be exogenous. So it's the exclusion restriction. Here, the main threat to that assumption is that surface level characteristics might also be correlated with the geological, hydrogeological features of the location. So I'm going to control for soil quality, elevation and slope. But also you have to keep in mind that in this setting, actually knowing where the subsurface water is difficult. You have programs by the World Bank using remote sensing data and combining that with geological surveys to try and really know where to put wells, because it's hard to know. And so that is one of the main motivation for my identification strategy. And so moving on to the preliminary results. So as I mentioned, the first step is that my instrument has to be relevant. So hydrogeological features should matter for water access. I'm going to first look at, and that's the most important part, if the time people take to fetch water is impacted by hydrological features. I'm relying also on the LSMS living standard measurement surveys in Tanzania to have that measure. The households are asked whether the time they take to fetch water. And it's also, the LSMS are also the data that I use for my migration measure. And I do find that hydrogeological features matter for the time people take to fetch water. Then I'm also, to check a bit further, looking at the functionality status of water points. So functionality status of a water point might be impacted by lots of different things, but the hydrogeological features do matter. And lastly, I'm also looking at boreholes to have a more comprehensive data on water points, and I'm looking at the yields of those boreholes, and that again might be influenced by lots of different factors, but hydrogeology plays an important role. And wow, I've talked really fast. And for now, so now so the first stage is secured. So I do find that hydrogeological features matter for water access. But for now, I don't find any significant impact on migration. So when I instrument water access with hydrogeology, I don't find any significant impact on migration. To come back to the previous talk, it's interesting because you also have like water shortage, and I saw that it wasn't significant also, so that maybe that just people don't move because of that. But I'm also thinking that it was really preliminary results, so I was using the hydrogeology of the main hydrogeological features of the region of origin, and that's a very noisy measure. And now I'm moving to a more specific, something that is a smaller scale, so the enumeration area of the household, so that I might attribute better the hydrogeology to the household. And another that doesn't work. Oh, okay. Another a next step that I want to look at, and is also maybe closer to a climate migration, is to look at the impact on to use a kind of an event study framework and exploit both the variation in the location, the geographical variation in hydrogeology, and the geographical and time variation in drought, to combine those two and see if, like, when wells dry up, that might have a bigger effect. Because for now, my instrument isn't time varying. Hydrogeology is fixed among like the lifetime of a human, and so having something that varies through time might make a better strategy. And that's it. Thank you.
Thank you very much, Lucy. I have a quick clarification question. You elaborated on what kind of sources you use to assess access to water from local populations, but I was curious to hear what kind of sources you use to assess migration or the movements of people. It wasn't very clear from the slides. Maybe you have that in mind.
No, I haven't.
Just so I understand better.
I'm also using the Living Standard Measurement Survey. So in that you have information on whether you have a migrant in your household. So I'm exploring different migration measures, because as I mentioned, I want to look at also the selection into migration. So one simple one is just whether the household has a migrant. And I'm also looking at whether the entire household migrated, but then you have less power because less people tend to have their whole household moving. And I'm also looking at whether you have a woman migrating, if the age of the migrant and the destination. And so, yeah, that's the Living Standard Measurement Surveys, is the data set that I draw on.
Yeah. So if I understood well, so your plan for the future is to control for rainfalls, right? In the meantime, because I guess, do you know whether households also collect water?
You have some rainwater collection, but also what is interesting in the LSMS is that I know the main source of drinking water, so I can kind of control for that. But it's mainly to also come back to this story of the disentangling between maybe economic migration and something that is more closer to forced migration, and having, like, if you have a drought, so a shock, then at first maybe it's at the beginning, it's mostly like economic migration. You have this shock, but once like the world dries up, then, but you have to have a huge variation in rainfall to have that. Then maybe the entire household or the selection into migration might change. So yeah, also precipitations.
Thank you very much for such interesting study. We also did the same study in Ethiopia some years ago and found out that there is a positive relationship between the time taken to fetch water, negative relationship between time fetched for water and the girls' education and the move to look for employment opportunities. When the scarcity of resources, household labor is required, particularly for girls, to fetch for water by walking long distances, and under that circumstances, they are forced to stay at home. But when water is made available to the household, there is less time required for girls, so that they have opportunities to look for that kind of things. And we found out that making these things promotes development in that perspective. But as already asked, I'm not yet clear what your data says. Have you done any household surveys yourself, or you are using existing data, and how do you put the two things together?
So if I understand correctly the question, I haven't, it's not me that gathered the question, the data, it's secondary like survey data. And then how do I relate that to the hydrogeological features is the question? Well, with their location. So I have, well, it's a bit more complicated than that, because you have some kind of a random factor that is applied, so to respect the anonymity of households, but you have the location of the enumeration area, which is close to like maybe the village or a bit bigger than the village in Tanzania. And you have the geographic coordinates for that with some kind of random variation. And so I use that to combine it with the map that I have of hydrogeological features. And so then I can know what's the type of geology underneath each enumeration area.